Hello, this is Mr. Combs, and once again, I have not been able to find a video that I like that deals with applications of equations, so I'm going to create, or I have created, my own, and this is it. So, let's talk a little bit about applications of equations, or word problems. And whenever I say the word problems, that usually strikes fear in the hearts of students. But really, word problems are a necessary evil. They allow us to practice applying the concepts that we've been learning in previous lessons, and really translating situations into equations that can be solved easily is one of the fundamental tasks of algebra. It's one of the reasons why we study algebra. Remember, we said at the beginning that with algebra we can take a situation, translate it into an expression or equation, manipulate that some way, solve, find an answer that will help us, or find a solution that will help us answer the question. And students often tell me that they hate word problems because when they look down at the page, they do not know where to start. They read a paragraph that's a word problem and they think, oh no, I don't know where to start. So my goal is for you to feel a little bit better about approaching word problems after you complete this lesson. What I've done is I've grouped these applications, or these word problems, into different categories. And the good thing about that is that the same strategy will be used to solve every application or every word problem of a certain category, or in a certain category, or of a certain type. So if you can identify the type of word problem you're trying to solve, then you'll always know how to begin, because you begin every single type of word problem the same way. I'm sorry, that's not what I meant to say. You begin every single word problem of a certain type the same way. So what we're going to do, and you have this written down on your information sheet for this week, on the second one, applications of equations, we're going to take the following general approach when solving word problems. We're going to first identify an unknown and let a variable or variable expression represent that unknown. Then we will create an equation, we'll solve that equation, and finally we will use the solution to that equation to answer the question posed in the word problem. So there are a couple that I want to go over first, just to get our feet wet, that basically do not have a certain category they fit into. These are just general word problems that we can basically look at the problem itself and use our general method and figure these out without grouping them into a certain category. You'll have a couple like this as you look at your homework. So let's look at the first one. The first one says, twice the sum of 4 and some number is 34. Find the number. So the first thing we have to do is we have to identify a variable. And, well, identify an unknown and let a variable represent that. So the thing that I don't know is the number. So it says find the number. So I don't know the number. So I might let n equal the number. Now what I need to do is I need to use the problem to create an equation. And now we've talked about creating an equation out of words before, and what we always said, or what we said we like to do, is start backwards and work our way back. So the first thing I notice is that I have is 34. So I know that something equals 34. And let's see if I can make my 3 a little bit better. Well, not having any luck with this 3. There we go. So then I know that I have the sum of 4 and some number. So the sum of 4 and some number is 4 plus n. Remember, because sum means add. Sum means addition. Okay, so then I have twice that sum. So I need to say twice, which is 2 times the sum. But if I just say 2 times with the multiplication symbol, the dot, then a person who's looking at this may think that I mean 2 times 4. But really I mean 2 times that sum. So what I'm going to do is I'm going to group the sum in parentheses, and I've created an equation 2 times 4 plus n in parentheses equals 34. Now I can solve that. So basically I'm going to multiply 2 by both sides, or by, not both sides, by everything in the parentheses. So I'm going to have 8 plus 2n equals 34. I'm going to subtract 8 from both sides. So I'll get 2n on this side because 8 minus 8 goes away. So I'll have 2n is equal to 34 minus 8 is 26. And if I divide by 2, I'm going to get n is equal to 13. So sometimes the solution to the equation isn't actually our answer to the problem. So we always have to go back to the problem and see what it actually asks. Here it says find the number. The number we said n was represented by n. So in this case, the solution is the answer to the problem, and n equals 13 is my answer. All right, if we look at the next one, it says the height of the Eiffel Tower is 974 feet, which is about 669 feet higher than the Statue of Liberty. What is the height of the Statue of Liberty? So if I identify an unknown, I'm going to say, what is it that I don't know? Well, I don't know the height of the Statue of Liberty. So I might let h equal the height of Statue of Liberty. Okay, so sometimes it's helpful to draw a picture. So I have this situation here where I have this Eiffel Tower. You're going to see that I should have been an art teacher. And I have the Statue of Liberty. Okay, now the height of the Eiffel Tower is 974 feet. So from here to here is 974 feet. The height of the Statue of Liberty, I don't know. So I'm just going to let h represent that. But I know that from here to here is a space of 669 feet because the Eiffel Tower is 669 feet higher than the Statue of Liberty. So isn't it true that if I add these two numbers together, they should equal 974, right? 669 plus h should equal 974. This is a very simple equation, but we've created an equation nonetheless. So 669 plus h equals 974. And if I subtract 669 from both sides, I think I will get h is equal to 305. Now remember, this is feet, so 305 feet. So h was the height of the Statue of Liberty. What is the height of the Statue of Liberty was our question. So we've answered it. The Statue of Liberty is 305 feet. Okay, so the next few problems we're going to look at can be broken down into certain categories. And like I said before, the good thing about this is that all problems of a certain category will be started and can be solved the same exact way. I'm not exaggerating. They're really, literally the same exact way. So once you know how to do one, you know how to do the other. So let's go ahead and take a look at the next few problems. Okay, let's look at consecutive integer problems. Now, when I say consecutive integer, what do I mean? Well, let's think about it. Consecutive means one right after the other. So if I have a consecutive integer, or if I have a list of consecutive integers, and let's say they start with 5, or the list starts with 5, then I'll have 5, 6 is the next consecutive integer, 7 is the next consecutive integer, 8, and so on. If I have 1, 2 is the next consecutive integer, 3 is the next consecutive integer, and 4, and so on. Alright, so what if I have x as the first consecutive integer? Well, how do I get from 5 to 6? What do I do to 5 to get 6? I add 1, right? What do I do to 1 to get 2? I add 1. So if x is my first consecutive integer, then the next consecutive integer is going to be x plus 1. Okay, and how do I get from 5 to 7? Or how do I get from 1 to 3? I add 2. So the third number, if I'm starting out with x, is x plus 2. And so on. So I could have x plus 3, x plus 4, x plus 5. Alright. We also may have consecutive odd or even numbers. So let's talk about these. Consecutive even or odd integers. If I have 5, what's the next consecutive odd integer? 7, right? What's the next one? 9, and so on. So to get from 5 to 7, I don't add 1, I add 2. So x plus 2. And to get from 5 to 9, I don't add 2, I add 4. So x plus 2, and x plus 4. If you think about even numbers, 2, 4, 6, 8, I add 2 to 2 to get to 4. I add 4 to 2 to get to 6. And I would add 6 to 2 to get to 8. So if I wanted to extend this beyond x plus 2, x plus 4, I would say x plus 6 for both odd and even numbers. Okay? So the idea behind a consecutive integer problem is you're going to have a number of consecutive integers, you're going to add those up, and you're going to set them equal to a number that's given in the problem. So for example, in the first problem, we have that the ages of Whitney, Wesley, and Wanda are consecutive integers. So how can I represent the ages of Whitney, Wesley, and Wanda? Well, I know they're consecutive integers. It doesn't say anything about even or odd. So I'm going to represent those as x plus 1, and x plus 2. Now I have my integers represented. I'm going to create an equation by adding these up. So x plus 1 plus x plus 2, and setting them equal to 108, which is the sum of the ages. Now I can combine like terms and solve this equation. So I really have 3x plus 3 equals 108. I'm going to first of all subtract 3. So 3x is equal to 105. And if I divide by 3, 105 divided by 3 is 35. So x is equal to 35. But did we answer the question? It says, what are their ages? Well, we want all three ages. So if Whitney is 35, how old's Wesley? Well, it's a consecutive integer. So Wesley is 36, and how old's Wanda? 37. So 35, 36, and 37 are the answers. All right, why don't you try the next one, and then we'll look at it together. Okay. Now here I have the sum of three consecutive odd integers. So now instead of dealing with x, x plus 1, and x plus 2, I'm going to be dealing with x, x plus 2, and x plus 4. Because this time I have odd integers. I'm going to do the same thing I did in the other problem. I'm going to set these equal, or add them up and set them equal to 189. So x plus 2 plus x plus 4 equals 189. So I have 3x's plus 4 and 2 is 6. So I have 3x plus 6 equals 189. If I subtract 6 from both sides, I'm going to get 3x is equal to 183. And if I divide, I get 3x is equal to 183 divided by 3. $61. Let's see. X is equal to 61. Okay, so it wants to know what the largest integer is. So the first integer, or x, is 61. The next one is the next consecutive odd integer, so that's 63. And the next one is the next consecutive odd integer, so that's 65. So the answer to this one is 65. All right, let's take a look at another kind of problem. Another type of problem are problems that I like to refer to as board and pipe problems. In a board or pipe problem, what you have is a distance or a length. And you're going to have a total then you cut the distance or the length into two parts. You're going to let one part be x. You're going to use the problem to tell you what the other part should be. And then what you'll do is you will add the two parts together and set them equal to the total. So you're going to add the two parts together and set them equal to the total. So let's look at this board. This is a 72-inch board. Go ahead and draw the board here. I know it's 72 inches from here to here. I'm going to cut it into two pieces. I'm going to automatically let one piece be x, and then I'm going to let the other piece be an expression that I get from looking at the problem. So if a 72-inch board is cut into two pieces, one piece is 2 inches longer than the other. So if I have x, how do I represent 2 inches longer than x? Yeah, 2 inches longer means add 2. So I have x and x plus 2 as variable expressions that represent the lengths of the two pieces. So if I add those together, x plus 2, I should get 72. So I really have 2x plus 2 equals 72, or 2x equals 70, because I'm going to subtract 2 from both sides. And then if I divide by 2, I'm going to get x is equal to 70 divided by 2 is 35. Okay, so 35 inches is the size of this piece. It says we'll find the lengths of the two pieces, so I need the other one. Well, the other one is just 2 inches longer than that. So 35 plus 2 is 37 inches. And I've got my problem answered, my word problem solved. Some things do not look like border pipe problems at first, but they are. If you'll notice in this next one, in 1997, Yanis Kouros of Australia set the record for greatest distance ran in 24 hours by running 188 miles. After 8 hours, he was approximately twice as far from the finish line as he was from the start. How far had he run? Alright, well, let's look. This is not a length this time, but a distance. So I have a finish line and a starting point. And Yanis is somewhere running right in the middle. So it says that he ran 188 miles. So from start to finish, it's 188 miles. And it says after 8 hours, he was approximately twice as far from the finish line as he was from the start. So if he's X miles away from the start, he is twice as far as that, so he's 2x miles away from the finish line. So all I'm going to do is say x plus 2x and set that equal to 188. So if I say x and 2x, I'm going to get 3x. Then if I divide by 3, I'm going to get x is equal to dropped my calculator. 62.6666, and it goes on forever. This is 62 2/3 of a mile. And it says that's x, and x is how far he was from the start. So it says how far had he run? Well, that's the distance in between start and where he is now is how far he had run. So 63 2/3 miles. That one's not so bad. All right, let's take a look at another problem, or another group of problems. These are percent problems. Okay? When I say percent problems, what I really mean is percent increase and percent decrease problems. So let's think about this. We can come up with a formula for each of these. So in each case, isn't it true that if I want to decrease something by a percentage or increase something by a percentage, I'm always going to start with the original amount, right? I'm always going to add or subtract, depending on what my situation is, some percent of original amount. So a percentage of the original amount. And this should give us the new amount. Right? So if I take the original amount, if it's 50% off, then I'm going to subtract some percentage of the original. If I'm adding sales tax, I'm going to add some percentage of the original. And then I'm going to set that equal to the new amount. In a problem like the ones we're going to be doing, the original amount will always be the unknown, so that will always be x. And then you'll always change that percentage into a decimal. And no matter if it's 0.50 and you just want to write it as 0.5, just so we can think about this as a decimal equivalent of a percentage, let's leave it with 2 decimal places. Of means times, and I have the original amount again. And the new amount will always be given. So really all you have to do is you have to fill in this blank and fill in these 2 blanks, and you've got it. You've got your equation. Okay? So remember that you always have an original amount plus or minus some percent of the original, and that will give you the new amount. So it's going to be x plus or minus point whatever x, 2 decimal places, equals the given. So let's look at the first one. It says at Amazon.com, Jake paid $14.78, including 6% sales tax, for a biography of Justin Bieber. How much did the book itself cost? Okay, I've got x